And we take kapak fiber, which is a fiber indigenous to the Philippines. And we put it into this. And now, first let's see if it floats. Okay, so the first test is that this, as it is, could be deployed into the water and it will float on top of the water. And it could be actually weighed down with weights so that we could submerge it depending on the weight we put on the bottom of it, and it would still travel. Okay, so, okay, that's good, it floats. Kapak will not hold water. It won't absorb. It doesn't wet out on water because it's cellulose. Okay? Now I just wrang it out, which I probably should not have done. However, I'm gonna put that back. Now let's take an oil. We'll make an oil spill. Okay, now I don't know absorption rate here, but hold on. Let's try this one also. Raw like this. It's not in a thing. Yep, see it's picking up. See this? Getting very jelly-like. This is floating. Huh. With the oil, it floats. Okay. With the oil, it floats. It does not sink. It does not sink. This absorption, I don't know how fast it absorbs. Okay, and I don't know what level it expands to, but this is substantially heavier than it was when it started. Isn't that good, huh? Wow. The issue here is going to be is if we're damaging the tubular structure of the fiber. But see the oil coming out of it? Wow. No water. No water at all, really. It's virtually all oil. And it's now let's put this back in. See what happens, if it will re-expand.
The cotton in the sack blocked the absorption of the oil.
We need a scale.
And then there's another question of what to do with the kapok afterwards.
It's recyclable. The system I have is a round system that goes around and around and around, squeezing the oil out as it passes through. It's a continuous system, and it will work. Through rollers, squeezing out the oil. The issue is the uniform, see this. More oil from the same, look at this, from that one that I took out. This is really strange, look at this. And I'm wringing it with my fist. Okay, I'm not ginger. So my theory was that because it's a tubular structure, it's like a straw, and the oil absorbs right through the cellular wall. it's not entering through the top of the straw or the bottom of the straw. So what's happening is rather than when I squeeze the fiber for the two walls to get crushed together, the oil is probably serving as a lubricant that's keeping them from sticking together and migrating. And it's regelling. Yeah, it's regelling. It's regelling. Yeah, my theory's correct. The tubular wall, usually if you pushed, this material is very soft, and if you pushed it together, it might migrate into one. But it appears that because the oil, if you can see my thing, the oil's lubricating the two things, they can't stick together. So when we put it back in, the straw is opening up and filling because it's coming through the cellular wall. This is also going to help us with succeeding absorption rates on succeeding cycles. The issue with, if it picks up 40 to 1 on the first thing, and then 37 to 1, 34 to 1, down in that sort of a spectrum, always how much residual oil is left in the straw before it goes back into the bath of seawater and or oil. And so the more open these pores are, the more oil it's going to go. And I guess the issue is getting it out, which in the squeezer, one of the issues I was thinking of is that if the only way to get this out is a drip system, which almost all the abstracts would from dripping, my thought was that, because you would damage the tubular structure, my thought was that heat affects viscosity of oil. So that we could have taken the tube and, as we were running it through, apply heat that would lower the viscosity, which would make it flow with a vibration bed that would allow for the oil to discharge from it. Heat going through the rollers, or even heated rollers, could very possibly assist in the discharge of the oil from the tubular structure. Let me give a little more oil. Bathe it. What the hell? It won't absorb water, so once we get a scale and we weigh it, now if I pour this right into it, it's not even going into the water. No, it's not. Look at this. It's not even going into the water. It's like a magnet. And it doesn't sink.
Okay.